Hello everybody, welcome to Science Abounds, Science at Home, where we will look at scientific concepts, principles and reactions by performing experiments in the comfort of our home. We will cover chemistry, biology, microbiology, microscopy and even forensic science. Welcome to my channel. Welcome everybody to this week's video. This experiment we are going to be looking at double replacement reactions. In my previous video we looked at the single displacement reaction where zinc displaced copper. So we started off with zinc metal and it displays copper from copper sulfate, and we ended up with copper as the resultant product. This week we're going to look at several double displacement reactions. More about that in a little while. But first, I just want to talk about some resources that would benefit you and resources that I use for me to set up my home lab. Where do I get my chemicals from, my equipment? So normally I do list them in the description of each of my videos, but I just wanted to talk a little bit about them in a little bit more detail for your own reference. None of these vendors or resources sponsor my videos, but they are my go-to resources for my home experiments. The first one I want to talk about is MEL Science. MEL Science is a subscription-only service, and you get one kit a month delivered to your doorstep, and each of the kits contain all the reagents and additional equipment that you may need to carry out the experiments within that kit. Each kit has enough resources to do the experiment at least twice, and usually there are 1 or 2 experiments per kit. And this is very a convenient way of doing science experiments at home without having to spend a lot of money on chemicals and glassware, because everything you need is provided by these kits. So I would strongly advise you, if you're starting out and doing experiments at home, to check out MEL Science and MEL Chemistry kits. They also do MEL Physics and MEL Medicine kits as well. Also, I would check out Carolina Biological. Basically, Carolina Biological is really my main resource where I get all my chemicals from, where I get all my kits from, experiment ideas, and in my future videos when I do some biology experiments, looking at microorganisms, looking at organisms, living organisms under the microscope, even dissection kits I can get through Carolina Biological. Another resource is the Home Science Tools. Basically, it's self-explanatory. They perform, or they provide, I should say, kits that support school curriculums and homeschool curriculums. You can buy kits for 1-year curriculum where it comes with all the reagents, all the glassware, equipment that you may need in order to perform those experiments. So I highly recommend home science tools. Another resource that I use is Innovating Science. And basically they are from Auden, and Auden provide these kits covering a wide range of experiments in chemistry and biology. For example, one here, I have a kit for chromatography of plant pigments. They do forensic kits as well, where you can explore forensic science. And I utilize a number of these kits in my experiments in my videos. So there are multiple vendors and resources available to you. I have listed all of them in my video description, so please do check them out for your own purposes. Thank you. So now back to this video, this experiment. We're going to be, as I've already said, we're going to look at several different aqueous double displacement reactions. Double displacement reactions is when two compounds dissociate in solution to form ions. Depending on the particular ions present and their concentrations, a reaction may or may not occur. The general form of a double replacement reaction is as shown. AB plus CD equals AD plus CB. For example, when silver nitrate reacts with sodium chloride, the silver ions and sodium ions swap places. The silver from the silver nitrate combines with the chloride from the sodium chloride to form a solid silver chloride, which precipitates out of solution. Double replacement reactions often result in the formation of precipitate, a gas or water, or sometimes a color reaction. And this is when we can tell whether a reaction has occurred or not. We are going to test 6 cations: barium, calcium, copper, hydrogen, lead, and magnesium against 8 anions: chloride, dichromate, ferrocyanide, hydroxide, iodide, sulfate, and sulfide, to determine whether a reaction occurs. Because we're doing several reactions, there are several different chemicals you're going to need for this experiment. I've listed the chemicals, which should be seen on the screen here. So you're going to need about 0.1 molar solution of each of barium nitrate, calcium nitrate, copper sulfate, lead acetate, hydrochloric acid, magnesium sulfate, potassium dichromate, potassium ferrocyanide, potassium iodide, sodium hydroxide, and sodium sulfide. All the recipes for my experiments can be found on my Patreon page for paid members, and you can follow step by step on how to do the experiments. And I also list all the reagents and all the equipment, the glassware and other equipment that you may need for that experiment. So please do check out my Patreon page, which I also have and post exclusive videos for my Patreon members that will not be shown on YouTube. So a couple of the reagents that I've made, that I have: hydrochloric acid, the sodium hydroxide, copper sulfate, and magnesium sulfate. I had to make up and do some dilutions to get the 0.1 molar concentration. So I've already completed and done that, so I'm now ready to go with the experiment. So for the purpose of this experiment, the reactions are going to take place in this 96 well reaction plate. And I've got a white background so I can observe any colors or any changes. I also have a black background, which will make seeing precipitates a lot easier as well. I've created a log where I'm going to record my results, and that's one thing that I do advise, is that you have a laboratory notebook to keep all your results in, and other additional information regarding the experiments. So always record your observations in your laboratory notebook. So I'm going to go by my log. So in row A, I'm going to add hydrochloric acid. In row B, I'm going to add potassium dichromate. In row C, I'm going to add potassium ferrocyanide. Row D, I'm going to add the sodium hydroxide. Row E, I'm going to add potassium iodide. In row F, I'm going to add magnesium sulfate, and row G, I'm going to add sodium sulfate to each of the 6 wells. And then I will then add each of the anions to each well. So let's start with row A. I got a pipette here, and I'm going to add 2 drops. That's all you need, of hydrochloric acid. So 2 drops to each of the 6 wells. Okay, you need a steady hand for this. So let's just spill a little bit on reaction tray. That's okay, just mop it up. So next, row B, I'm going to add the potassium dichromate. Again, 2 drops in each well. Okay. Next, in row C, I'm going to add my potassium ferrocyanide. Okay. In row D, I'm going to add my hydroxide. Which I have here. So row D. 1, 2. Okay. The next row E, will be potassium iodide. Next will be row E. So F, it will be my magnesium sulfate. Okay. And then my last one will be the sodium sulfide. Okay, so I've added my reagents now. So I've added my anions to my reaction wells. Now I'm going to add the cation to the reaction wells. So now I'm going to add the cations, and again 2 drops of each cation, and I'm going to go down instead of across. So in row 1 I'm going to add barium, 2 drops of barium nitrate. We'll see what kind of reactions happen. Okay. So with the barium chloride, I see a reaction, and you can so with the barium nitrate, wells D, F, and G, I got a white precipitate. So I'm going to record that on my chart. And I'm going to indicate white precipitate. Okay. Next, I'm going to add my calcium nitrate to well row 2. Again, 2 drops of each. So for the calcium, I got a reaction in well D, a white precipitate, and in G, I got a white precipitate. So now we go on to the copper. So I'm going to add copper. Okay. And let's check this against the white background, because you can't really see it on the black. So for the copper, I got a reaction in well C. So I got a slight dark or slight brown color precipitate. In row D, I have a slight blue color solution. And then I got a dark black color in well G, a black precipitate in row G. So next, I'm going to add hydrochloric acid to row 4. Okay. So next, I add the lead acetate to row 5. Okay, and I got a lot of different reactions here with lead cation. And finally, we're going to add the magnesium to the last remaining well. So in here, I got a reaction in well G. I got a brown precipitate. Okay, a lot of things were going on in today's experiment, a lot of reactions. We saw several displacement reactions occurring. This is my log of my recorded results, and as you can see, there are several reactions occurring indicating a displacement reaction occurred. So let's break everything down and take a look at some of the individual reactions that occurred in today's experiment. I'm not going to go through every reaction because there's just too many, but if you check on my Patreon page, I publish all the recipes for all my experiments that you can follow along and do them in your own home. And I also provide notes, video notes about what is going on in the experiment and give a background information and explanation of all the reactions. So you can get a whole list of the reactions from those recipes that can be found on my Patreon page. But as you saw from the experiment, that a lot of the reactions formed precipitates. So what is a precipitate? A precipitate is a solid that comes out of solution. And the precipitation reaction is when two soluble salts react to form an insoluble product. And that's what we saw. And you'll see in a minute what those insoluble salts were. And a precipitation reaction is commonly seen and commonly occurs in a double replacement reaction. That is when there are two salts that are soluble and when the cation of one binds with the anion of the other, it forms a solid product that is not soluble. And that's what we saw today. Let's look at each of our reactions to determine what is happening. If we take a look at B1, where we reacted barium nitrate with potassium chromate, this forms barium chromate. Barium pairs with the chromate ion to form barium chromate, and the potassium pairs with the nitrate to form potassium nitrate. This is a double replacement action because the barium chromate is less soluble in water, and that's why we got a slight precipitate in our reaction well. In B5, we reacted lead acetate with potassium chromate. The lead combines with the chromate ion to form lead dichromate, and the potassium forms with the acetate to form potassium acetate. It is the lead dichromate which is insoluble and precipitates out. The potassium acetate is soluble in water and remains in solution. In C3, we had copper sulfate react with potassium ferrocyanide. This gives the formation of copper ferrocyanide, which is insoluble in solution. And that's why we got a slightly brown color precipitate. In D1, we reacted barium nitrate with sodium hydroxide, and we got a white precipitate of barium hydroxide. Now, it was only a partial precipitate. It wasn't in your face precipitating out of solution, but we did see a slight partial precipitate because it is slightly soluble. In D2, if we look at D2, we got a white precipitate. Again, it was a partial precipitate where calcium nitrate, and sodium hydroxide react to form calcium hydroxide and sodium nitrate. The calcium hydroxide is, again, it is soluble, but only sparingly. So that's why we get a partial precipitate. Some of it solubilized, some of it precipitated. D3, we reacted copper sulfate with sodium hydroxide. The copper reacted with the hydroxide ion to form copper hydroxide and is insoluble and precipitates because of the copper, giving a blue solid precipitate. In reaction D5, again, we saw a white precipitate, and this is from the lead acetate reacting with sodium hydroxide, producing lead hydroxide. And again, it's the lead hydroxide which is insoluble and forms the white precipitate. The last reaction we're going to look at is in G3, where we reacted copper sulfate with sodium sulfide, producing copper sulfide, which is insoluble and forms a black precipitate. This black precipitate can be used as a qualitative screen for the presence of copper, and a lot of screening experiments, if you want to determine if copper is present, is by measuring the formation of this copper sulfide. Okay, so that was a lot to take in, a lot of reactions going on, and the purpose of this experiment was to illustrate several double displacement reactions and how we can determine whether a double displacement reaction occurred or not. I hope you enjoyed this video. Please hit the subscribe button, hit the like button and share button. It all helps me support this channel and keep producing it. Also, check out my Patreon page where I have exclusive videos of experiments with which are extended in time because they go into more depth. There's more theory behind them. Also, you can access all my experiment recipes for the experiments that I do on my Patreon page and on my YouTube. Can be found on Patreon. Email me all your questions, send me your photos and videos. I want to see you doing your experiments at home, and I would love to exchange and share your experiences. Until next time, keep on experimenting. Goodbye, everybody.